it's really important to be able to see these things in action. And that's why we're going and building, pretty complex programs, because I don't want to give you a toy project. So our prompt manager is like 10,000 lines of code. It's pretty complex stuff. So we're going to work in that and do dependency injection and testability and other things. We'll extract out a pure domain model from our prompt manager so you can see how it works. And I'm excited to share that with you. So let's dive in. Hello world, I'm David Scott Bernstein and welcome to The Passionate Programmer. We've been working on building a prompt manager for the last several weeks, and it's grown quite significantly. In this video, we'll use safe refactoring techniques from Michael Feather's book, Working Effectively with Legacy Code, and Martin Fowler's book, Refactoring, to clean up our code without breaking anything. These are critical techniques for growing quality software. So here's our send message, one of our routes. And notice it deals with a lot of issues. It does HTTP parsing, it does validation and provides lookups for the provider. It builds a message array, does token trimming, LLM calls, and token updates. Quite a lot of stuff. 6 responsibilities in one function. Can't test the message building without mocking Flask, the LLM provider, and the database. This is a mess. Let's fix it. So Claude is extracting out the message building into its own function. No Flask dependencies, no HTTP, just pure business logic. It takes 3 inputs and returns an array. When you see green lines, that's new functions added. When you see red, that's lines deleted. Let's take a look at what Claude did. So it extracted out building the message array into its own method. Yes, let's keep it. All right, now the main function has been reduced. Instead of 16 lines, it's now 1 line. Let's verify that it all works again. So I'm going to ask Claude to run tests. All right, great. We got 33 passing tests. Perfect. I think we're not done. We still have some token related stuff going on. So I'm going to ask Claude to remove this token trimming logic and extract it into its own function. We've taken out the trimming and the token management and added a call to a method. Yes, let's keep it. Excellent. Run all tests. And there we go. They're all passing. So that is excellent. Very good. All right, what's next? Well, I saw something that really bugged me. And I think right at the top of this file here, look at lines 15, 16, and 17. We create managers for the provider, for the conversation, and for the token. This is global variables, and it's really messing up our testing because I can't test a bunch of things without instantiating these, and I can't instantiate these without keys and files and all sorts of other stuff. So I want to get these out of the equation. And what are my options? I really only see one major option, which I use all the time, and it's a technique that is super valuable called dependency injection. And dependency injection, you've probably heard of dependency injection frameworks like Spring. Well, we're just doing this manually. Instead of instantiating these guys and passing them around, we inject them to the callers that need them. And this gives me the freedom to inject a fake instead when I'm in testing mode. That's the idea. It's really powerful. And we want to write unit tests against all of our code so that we verify that it's still working. This is especially important when we're working with AI because it's very easy to get lost and it's very easy for AI to get ahead of itself and wind up messing up things. We do this all the time as developers. And that's what regression is all about. It's about being able to run tests to make sure that the system continues to work as expected. Notice here in send chat message, we're accessing these globals, provider manager, token manager, etc. And we cannot test this code without instantiating those managers. And we can't instantiate those managers without instantiating a lot of other stuff. And so we're in a vicious cycle. What we want to do is replace instantiating these managers with injecting these managers instead. So we'll pass them in. And this is going to give us the freedom in the future to pass in fakes instead when we're in testing mode. Every place that we use globals, we're now going to inject the dependency instead. So I'm going to ask Claude to replace our global managers with dependency injection, run the tests, and then tell us what they learned. You can see here on 226, it replaced provider manager with provider MGR. And that's the pattern. This provider.mgr is the fake. Okay, and it's going to do that for all of them. That's excellent. Okay, Claude, let's run our tests again. And it looks like all our tests are passing. So that's excellent. And just to show you really quickly, we have replaced all of these managers with fake managers. So let's run our tests and prove that we didn't break anything. All right, all green. That's the discipline. Every refactoring keeps our tests passing. So here are the replaced methods. This is where we're injecting the dependencies. So instead of instantiating these managers, we're instantiating these MGRs, and they're basically gotten from a config. So what have we learned? In 10 minutes, we've applied 3 legacy code techniques to fresh code. We've extracted methods, which revealed a hidden domain concept. Message building and token trimming were hiding in that 78-line function. We did dependency injection. We made untestable code testable by removing globals and replacing them with injected dependencies. Now tests can inject mocks instead of using globals. We wrote tests as a safety net. We ran our tests after every change. Green tests means we didn't break anything. The function is shorter, clearer, and more testable. But we're not done. In the next episode, we'll extract those domain models properly, and I'll show you domain-driven design in action. You won't want to miss it, and I'll see you there. Happy coding.